Hi, and welcome to the 7th tutorial in the Retirement Simulator Python Millionaire, I said that backwards, Python series, where we are creating a retirement simulator so that you can be a trillionaire as long as you work for 1,000 years. And that's what we can show in a simulation. You can show anything, which is great. We aim to make a realistic simulation of a retirement scenario, and we're going to show how you can add all the custom things that make you a different person. But while we're getting to the last time, we were looking here and we did this, we plotted the histogram of our X distribution, and we saw our Gaussian shape, which made us feel thumbs up, good. And then we did this nice little sys.exit to quit everything. Here's what we're going to do. We're going to comment that out. I'm going to probably end up working for the rest of the time in this editor because it will show up a little bit better without wrapping lines. But I have Spider here. We can always go back and make sure that everything I update shows up here as well. And so we go back to our retirement simulator here. And what I've done first is I'm going to comment out this plot.show and sys.exit because we don't want to show the plot yet and we don't want to quit the program. In fact, you can just delete them if you like, because I don't think we'll use them again. But what we're going to do now is, in fact, since we're plotting things, we're going to make our plots a little organized, and we're going to have more than one plot. So this is going to be a nice little portion of the Python exercise where we're going to figure out how to make a plot with multiple subplots. And it's relatively easy. In fact, this method I'm going to show is something I just learned. It's not the way that I had been doing subplots, but apparently it may be a new method. It's relatively straightforward, so I'm going to teach myself it while I'm teaching it to you. We're going to start by, we have already imported matplotlib.pyplot as plt up here at the top. Okay, just copying, showing you that. And so back down where we just stopped, right about line 108 in mine, we're going to say fig, comma, axs for axes equals plt dot subplots 2. What that means is we want to make a 2x2 grid of plots. So instead of just having one plot, we're going to have 4 plots. Okay. So this is a quick syntax to make that arrangement. And what axis here has a structure where axis is something that looks like you have, it's a 2x2 array such that axs 0, 0 is your first plot, and then axs 0, 1 is your second plot, and so on. Hopefully you can figure out the pattern there. The next plot would be 1, 0, and the final plot would be 1, 1. So, that being said, we want to now, everywhere where we said plot.show, we need to change to invoke the axis that we actually want to plot on. So, it looks like we don't have anywhere we're plotting again yet, and that's okay. But the next thing we're going to want to do now, so we've just invoked this thing to make a subplot with 4 plots on it. We want to populate that with multiple plots. So one thing we want to plot, we'll continue to plot the thing we were plotting originally, the plot hist. In fact, so that's actually what we want to turn our attention to. Everywhere we've said plot.something, we need to tell it which plot we want it to go on. So in fact, this fig axis thing should probably go up much higher, and we can put it up here. Yeah, maybe, I guess we'll put it up here around line 76, around where it says rate bins. Okay, so we're going to invoke it there, and then we're going to take this axis 0, 0, our first subplot, and everywhere where we said plot.something, so like here we said plot.hist, we want to change that to axs00.hist. Okay, and I find in this editor, if you double click something to highlight it, it shows you where all the copies of it are. So there we want to copy, and at the very end of this now we'll do a we still do plt.show for the final show. I'm going to save this, and I'm going to go to this thing here and run it. Python retirement _ simulator.py. And hopefully we don't have any errors. But now we see we have 4 different plots, and we're only plotting on the very first one. So this is the behavior that we wanted to see. And I do believe you can see all of these plots here in the window, which is great. All right, so we will kill that. And it's still printed to the screen, all the things we were printing originally, which is great. Okay, so far all we've changed is just we made our what was a single plot. We've created an instance of a figure. We've created subplots that we can plot different things on as we want to. Okay. Let's see. The next thing that we need to do is to we want to make now a separate plot, and we're gonna make on one of the plots. I think it would be interesting to see, we could plot how our retirement is actually growing over time. And in fact, I'll show you something called plt.pause, which will allow it to update as the program is running, which for very light instance animations is not a bad use of the plt.pause feature. So again, plt.pause is something that I learned about very recently. You're going to want to scroll down to your while loop area, and what we're going to want to do here is outside of the while loop, we're going to make a definition. We'll call it money empty list, dates empty list, and we'll just say I equals 0. I is going to be an iterator that we may use inside our loop. So right after we get in the loop, we're going to say I plus equals 1. And so that's just every time the while loop goes through an iteration, I is going to iterate. And we're going to keep track of that because here at the bottom of the loop, we're going to keep track of how much is in our retirement and the day's date. So after we've added money to our retirement, yes, and paychecks per year and all that stuff, you want to make sure everything is the way that you want it, but you want to still be inside the while loop. Now you'll say money.append retirement dates.append today's date. And we can start by doing it the inefficient way, and then we'll show you the efficient way. So the inefficient way would just be to say AXS 0, 1 dot plot dates, money. So that's going to plot dates and money every single time it goes through the loop, which will be a lot of times perhaps. And then we would say then plt.pause. And the thing you enter here into pause is a number. And the number you enter, it may have a default number, I don't know. We're going to just enter a very, very small number so that basically it pauses as little as possible. It's going to, it'll probably be longer than this. This is maybe a number of milliseconds, maybe a number of seconds, whatever the case may be. It's going to be longer than that. And so we just put in a small number that's not ridiculously small, and we move on. So I think that we're good to go. We have a plot.show here at the end. I think this plot.pause is the correct way to say it, even because we've invoked the AXS01 here. So we saw the plot with only the one plot filled and all the other ones empty. Now we should see something different. So we will run this again and see what we see. All right, so we can see that this is changing colors, and this axis is moving, this axis is moving. This kink here indicates, I think, that we hit a new year with a new interest rate. Kink is a new year, new interest rate, new year, new interest rate. And the reason that it's kind of flashing different colors is because it's literally generating a new plot every single time there's a new point added to this thing. And so you can see it grows very slowly, and I think it gets a little slower over time because it in fact eats up a good amount of memory. And so this is where we end up in this particular simulation with over $100,000 in our savings account, and all those plots are plotted on top of each other. So we'll close that, and we're going to use now this I so that we don't plot quite as often. So we'll say if I percent, we can say, I don't know, anything, 25 double equals 0. And so I percent 25 just means that it's the terminology is modulus, I modulus 25 or modulo. And what that means is basically every 25th iteration, that's what the equals 0 amounts to, then do this function or do this thing. So every 25th iteration will invoke a plot and a pause, and then we'll go back into our normal loop. And so this should in fact speed up the plotting quite a bit. So let's see what that looks like. Retirement simulator.py. All right, and yes, so that was much faster. We still get the same kind of plot. Had a big year, had a big loss. Kind of came back to a normal feature here, but obviously didn't do so good. Ended up with 37,000 or so rather than 100,000. So not the greatest simulation. But you're starting maybe to see how much of a difference using these randomized values can have, which is the whole point. And so really, we don't want to do one simulation. We want to do a bunch of simulations. So in the next tutorial, we're going to just show putting this into a loop, which you can probably figure out on your own, but if you can't, you can stick around for the next one. And we're gonna show how to put this into a loop and still populate this plot with all the different plots to see how maybe 1,000 different simulations of this retirement scenario would work out, and we'll continue to move on from there. But thanks for watching this one, and I hope you stick around for the next one.